Good morning, this is Professor Shannon Gracie back again. We are in our Precalculus 1 class and we are using the Precalculus Enhanced with Graphing Utilities text by Sullivan and Sullivan. So let's start out by warming up. Today we'll be learning how to solve equations using a graphing utility. So pause the movie and warm it up. Okay, let's see how you did. This is a very important skill, what this warm up here for when you're using the graphing calculator, because you need to isolate the dependent variable in terms of the independent variable in order to graph things on your graphing calculator. So let's see what we have going on. If we add x to both sides, we will have negative 8y is equal to x plus 7. And then dividing both sides by negative 8, you could either write this equation as y equals negative quantity x plus 7 all over 8. Or if you wanted to distribute through both the negative and the 8, you would have negative x divided by 8 minus 7/8. Either format will work well using the graphing calculator. Okay, next up, part B. Again, we're going to be moving the x term on the other side. So if I subtract x cubed from both sides, I'll get negative 2y is negative x cubed plus 6, dividing both sides by negative 2, or multiplying through by negative 1/2, we will have y equals, and in this case, I'm just going to write it as distributing the negative 2 through these two terms. So we'll get x cubed over 2 minus 3. So here we go. Solving equations using the graphing calculator. When you use your graphing calculator, usually approximate solutions are obtained, meaning the number's often been rounded. So unless we have some sort of problem where it's useful to go more digits, we'll be rounding approximate solutions to 2 decimal places. The zero or root feature of a graphing calculator can be used to find the solutions of an equation when one side of the equation is 0. And using this feature, we make use of the fact that when the graphing of an equation in two variables, x and y, crosses or touches the x-axis, then your y variable is 0. For this reason, any value of x for which y equals 0 will be a solution to the equation. That is, solving an equation for x when one side of the equation is 0 is equivalent to finding where the graph of the corresponding equation in two variables crosses or touches the x-axis. So let's check this out. Now, there's a couple ways you can look at this first step. Like in our warm-up problems, you could isolate y. And then, I should have added this in, you'll have y equals some expression in x. And then if we call this 1a, right? So we could set y equal to 0. So then, once you do that, you'll have 0 equals some expression in x. Good so far? So basically what you're doing is you're finding the zeros of this equation, the zeros for x, which are also the x-intercepts. So then you're going to graph y1 is equal to this expression in x. Right? So this is what you're actually solving. So by doing this, you're not actually setting yourself, you're not really setting y equal to 0 until you use this command right here on your graphing calculator. So when you do this part, what we should say is this step sets y equal to 0. So 0 ends up being some expression in x, and that's what you find in step 3. So you use 0 or root to determine each x-intercept of the graph. So if you only have an equation in x, the way you would change this is you would be focused on this part here. 0 is some expression in x. So the first case is where you have a y as part of your equation. If you only have an equation in one variable, then you would get 0 on one side and you'd have your expression in x or whatever the variable is on the other side. So let's see what we have here. We're going to use the 0 or root function to approximate the real solutions, if there are any, of each of these equations, and we'll round to 2 decimal places. So notice that for parts A and B, both of these are already equal to 0. So this method is perfect to use for solving this equation. So let's get our graphing calculators out. So let me clear this, and we'll clear this. So, and I'm going to make sure I'm at Zoom standard to start out with, and we'll go to y equals. So we have -3 times x, and this means it's going to be raised to the 4th power, and just that x is raised to the 4th, plus 8 times x, and in the square key, you've got that available there, and then minus 2 times x minus 9. So if you graph this, so this is what we entered in. So next, let's graph this. Oh, and so clearly I made an error. So let's see what error I made. Oh, I did not need this parentheses right here. I don't know why I have that. So let me paste this. Okay. So if you take a look here at this graph, you'll see that it doesn't look like it's going to touch the x-axis, at least not in this viewing window, right? But that doesn't mean it won't ever cross. I think we're good to go, and we'll learn this later, but we have a negative coefficient in front of our leading term here. So this may indeed be something where we do not have any X-intercepts. But if we go to zoom, and there's a zoom fit key, and sometimes this works to give us a bigger picture or a more complete picture of the graph. Let me see what this window is. So it's still negative 10 to 10, but what it did is it decreased the y values. Do you see that? So let's go ahead and let's put the maximum y value to 1. Graph it again. And the y values are so huge, so it looks like it's touching the axis here. Do you see that? I don't think it is, but what we can do, I'll walk you through how to find out if it is or not. So what we would do is we would say, we would go to second, calculate, and 0. So this is what we're selecting right here. And if we hit enter, the left bound is here. Y is negative 9, so that's below 0. And then what you can do is you can kind of go over here and see if y ever, do you see it never crosses 0, right? So basically, it's at negative 9. I scroll to the right. It seems to be getting closer to 0, but then it starts getting further away. So if I hit enter here and then enter again, it says no sign change. So basically that means it doesn't cross the x-axis, right? So let's quit out of here. Let's zoom out again. So I'll just hit zoom out, get a better picture of the graph. Actually, go back to that standard zoom. This was our initial picture, and that seemed actually to be a good, honest picture of our graph. Sometimes, you know, you don't see the whole thing, but this one turned out to be a good picture. So what we would do here is we would say there are no x-intercepts. So if you were solving this equation algebraically, what you would find is that you would get an imaginary, you would get probably 4 imaginary results, 2 to 4 imaginary results. So we would say no real solutions. Right? So just put that down there. Okay, so let's look at part B, and hopefully this one will have real solutions so we can get a feel for how to use this feature. So going back to y equals, clear this out. This one is x cubed minus 8 times x plus 1. And we'll graph this one. Okay, so here is the picture of the graph. It clearly crosses the x-intercept, or it clearly crosses the x-axis. So what we're going to do is go back here. We're going to go to second, calculate, 0 again. Enter. Now, the left bound, do you see is just above the x-axis? Right? So we're going to hit enter. Now you have to scroll until you have a sign change. So do you see now that the negative value is there? So now I'll hit enter on that. Then it says, hey, why don't you guess and see what you think? So go ahead and give your best guess. And then let's see what the answer is. So what we have found is at x approximately equal to 0.13, because we're going to 2 decimal points, then y is equal to 0. So if we put that in roster notation, we would write 0.13. And by the way, this would be the empty set since we were looking for real solutions. So in summary, once you are in the 0 part of the menu in your graphing calculator, you either go above or below the x-axis and click enter. Then you go to the opposite side. So in this case, we were above the x-axis and we were on the graph and we hit enter. Then we scrolled to the right, which traced the graph and brought us below the x-axis. We hit enter and then enter again, and we got our result. Okay? All right. So another feature is the intersect method of solving. So to use the intersect method, this is what you do. You don't do the work to get 0 on one side, and this is going to be this works for several different applications, but when you're dealing with examples like this where you just have one variable, what's happening is we're going to graph 2 lines, and we're going to see, or not lines, but we're going to graph 2 equations and see where they intersect. Oh, and we've got a typo here. My bad. This is not the 0 or root. This is the intersect. Okay, so here we go. You're going to graph y1 equals the expression in x on the left side of the equation, and y2 equals the expression in x on the right side of the equation. Then we use intersect to determine the x-coordinate of each point in the intersection. And that will be our answer. So, bringing our calculator back and go into the y equals screen. We'll clear this out. So on the left side, you see we have negative x to the 4th plus 1. And then on the right side, we have 2 times x squared minus 3. So this is what was entered in. And then coming back, we'll hit graph. That's kind of a cool graph, right? And by the way, if you want to graph using, if you wanted to graph using different lines, you would go here and you can pick different things. If you hit enter, do you see how that's a more bold line? Hit enter again. You can graph like the region above if you're doing a greater than, region below for a less than. This one, you know, there's just some different types of graphs. This one doesn't show up as much. I'll go ahead and do this one in the solid line and then go over here. So let me recopy this one so you guys can see what I did. And then our picture of our graphs. Then that way we'll know which one is which. So that's Y1 and this one is Y2. That's our basic graph. So now let's see how to use the intersect feature. If you go to second, calculate, and the fifth selection there is intersect. So what's going to happen on the intersect menu is you will be, it will ask you which one is the first curve. So do you see that it is blinking right here on the Y1? So this is what it'll look like here. And then you hit enter, and then you go to your second curve. That's the one that we want to do for this one. And then you hit enter twice. And the intersection that it gave us, it's hard to see because of this bolded one, but it gave us the one where x is positive. Okay. Now, we have another point of intersection. So this is the one on the positive side. And now we need to go to the one on the negative side. Now, I think it's just going to be the negative of this. Actually, we go back to the intersect. So we need to cursor over here so we're closer to this intersection point. And you do the same thing. And, as I said, it's just the negative of the x value that we found here. And you can tell which one, not only by the dot on your graph of your, that the graphing calculator gives you, but you can also see from the values below. So this gave us this intersection point, and this one gave us this intersection point. So basically, this is the ordered pair where it happens. And so our answers will be going to the nearest hundredth. We'll have negative 1.11, and we'll have positive 1.11. And those are the x values that yield that are solutions. So why don't you try this next one on your own and see how you do. And check with you in a moment. Okay, let's see how you did. We'll move a little bit more quickly. So our y equals, on this case, will be the left side will be, clear these out, we'll have 1 divided by 4 times x cubed minus 5 times x. Enter. And I'm just going to leave the, the width of the lines alone this time so we can see the intersection points better. And the second one is 1/5 times x squared minus 4. Okay, so it looks like, do you guys see we're going to have 1, 2, 3 intersection points on this one. So let's start with the leftmost. So again, we're going to second calculate, intersect, and I'm going to cursor all the way over here because we want to be nearby our intersection points. So I'll go to this here. That was our first one. Here's our second one. And here's our intersection point. At approximately negative 4.47. So moving right along, you just do it all over again. Second, calculate, intersect. But now we have to make sure we're closer to the one over here. So as long as you're closer to this one than any of the other ones, you can start hitting enter. Okay. So at x equal to 0.8, we have another intersection. And then our last one will be, we have to cursor closer to this guy. So enter, enter again, and a third time. And we've got our intersection. So again, these values here give us our intersection points, so our x-coordinates where the intersections occur. And that's where this would happen here and here. So x will be negative 4.47, 0.8, and positive 4.47. You're good to go. All right, so the next series of examples basically ask you to solve each equation algebraically and then verify your solution using a graphing calculator. So you can pick whichever method on the graphing calculator that you want to use, whatever is easier. And just to point out on example this 3b, what's happening is you have an expression in y, but notice that our graphing calculator is set up for expressions in x. So when you're plugging things in on the graphing calculator, you will substitute in X for Y so that we can graph it. It would be very difficult, if not, impossible to change the independent variable to Y on your graphing calculator. So here we go. Let's see what we have going on. And I highly recommend that you pause the movie and try these on your own and then check your work. But if you'd like to just go for the ride, here you go. So if I distribute that negative through, I have 5 minus 2x plus 1 is equal to 10 minus x. So negative 2x plus 6 is equal to 10 minus x when I combine the 5 and the 1. Subtracting 6 from both sides, we'll have negative 2x is equal to 4 minus x. And adding x to both sides, we'll have negative x is equal to 4. Dividing both sides by negative 1, we have x is negative 4. So, algebraically, we got this result. Now, this one is set up for, when I look at this one, it seems like the intersect method would be the friendliest, right? Because otherwise we'd have to move everything over anyway to get a 0 on one side. So let's see what we have going on with the intersect method for this one. So my y equals, if I clear this and this, my y equals will be 5 minus parentheses 2 times x minus 1 end parentheses. And then on my y2, I would have 10 minus x. And let's see what we get. We graph it. Now here, let's see. Do you see that we cannot see the point of intersection with the window that we have here? So I'm going to put, again, I'm going to zoom out this time. I'm going to zoom out and see if we can get a nicer picture. There we go. Do you see how we now have a picture of the intersection? So we go to our Calculate menu and select Intersect. There's only one intersection point, so we don't have to be careful about where we press. And we got it. The intersection occurs at the ordered pair -4, 14. If we're thinking about a system of linear equations, we would give both, but we were only solving for x. And notice that it matches, right? We got x is -4. So, check. All right, let's do this guy. So I want to clear out the fractions when I am solving this. So if I multiply both sides by 2y, I can clear those out. But be careful, because you're going to be distributing the 2y throughout. And on the right side, we can go ahead and divide out this 2y, and we'll get 18. So on the left side, this y divides out, but we still have the 2 multiplying to the 4. And then we'll have, whoops, minus 10y is equal to 18. Subtracting 8 from both sides, we will have negative 10y is equal to 10 and dividing both sides by negative 10, we'll get y is negative 1. So our solution set would just be negative 1. So let's check and see if it's right. Now be real careful here because you're going to be entering this in terms of x. And again, this is set up for, I'm going to just go ahead and zoom standard again. But this one here is set up for y is an independent variable. But so we are going to have to when we enter it into the calculator, substitute it x in for y. So that would give us 4 divided by x, and then minus 5 for the left side of our equation. And then we have 18 divided by, be careful, you have to put parentheses around the product. Otherwise, it would enter it in as 18 divided by 2, and then you'd be multiplying by the variable instead of dividing by it. So if we graph this one, that's the first graph, and that's the second graph. So I think we can see our point of intersection right here. So if we go to our Calculate menu and go to Intersect, where is it beeping at? Here we go. We have this one and this one, and we got our intersection. So be careful. I know it has something for y, but we're going to ignore that y is negative 9 because remember we substituted in our y equals menu. We changed y to x in order to use the technology. So this one here matches what we got for our result. So that checks. All right. How you doing so far? Great. Awesome. So part C. Do you see that we could, let's try factoring by grouping and see how that pans out. So we can factor out an x squared from the first one, and we'll get x plus 2. And then from the second one, if we factor out a negative 9, we'd be left with x plus 2. That's equal to 0. I'm sorry, I don't know why I keep doing an equal sign right there. We want to just have the equals. Since we have an equation, we'll keep it in between the expression and the 0. So now we have a common binomial factor of x plus 2 that we can factor out. So we'll have the quantity x plus 2 times x squared minus 9 is equal to 0. So we get x plus 2 is 0, or x squared minus 9 is 0. If you square root both, well, we have to do one more thing here. X squared would equal to 9 on this side. And if we square root both sides, we will get x is plus or minus 3 by the square root property. And over here, if we subtract 2 from both sides, we'll get x is negative 2. So our solutions that we found were negative 3, negative 2, and positive 3. So let's check to see how we did. So this one is set up really well for the 0 or root feature of the calculator. So I'm going to go ahead and, graph the original, which was x cubed plus 2 times x squared minus 9 times x minus 18. We're going to graph this. And, let's zoom out a little because I don't think we saw the whole picture of that graph. There we go. That looks better. So here we go. Let us that's a little too far out because it's really difficult to see at the zeros. Let's look at our window here. Why don't we try setting this at negative 20 to 20 instead? And the y max we can set at the same. And see what that one looks like. It's a little friendlier. We ditched out on the bottom part of the graph, but at least we can see it crosses the x-axis, it looks like here and here. So now if we go to second, calculate 0, let's go to the leftmost 0. So it's very close together, but you're going to get 2 zeros over here. So you look at this y value here, you want to be below, you want to have a negative, and then you hit enter. And then if we go above, do you see how now it's positive? So I'm going to hit enter again. And then we'll get our result of x equals negative 3. And next up, if we go back to second, calculate, and then 0. Now we want to go a little bit more to the right. You see y is positive, hit enter. Cursor to the right till you get a negative. And we got a negative y. Hit enter again. That means we've crossed the x-axis. And we got at x is negative 2, we got another 0. And then for our last one, go to second, calculate, 0. Oh, whoa, whoa. All right. So you see y is negative here. Cursor to the right till it's positive. Hit enter. And it landed right at the 0. And our original that we had entered in, and our y equals was this. Okay, so we have verified. So we got this solution here. The x is 0, or I'm sorry, x is negative 3, x is negative 2, and x is 3. So that checks out. Alrighty, so you know what? That wraps it up for today. A little shorter. Just be prepared. The next one is all about lines, so it basically has, something that you learned over several sections of intermediate algebras and one section of Precalculus 1 or college algebra. So anyway, just keep that in mind. Give yourself some time for your next lecture. All right, have a fabulous day. Don't forget to do your homework. All right, bye.